Welcome back after that brief break. This is day number 2 on this. I have pulled the bed off of the Monster D9 and I'm taking a look at it. I'm thinking that what I'm going to have to do here is I will have to, first of all, I'm going to remove these wires. I have to unsolder these here, and then this thermistor just comes out and I'll pull off the Kapton tape. And then this shield is going to have to come off because my heater is going to cover the entire bed corner to corner. In order to get this support rail off, I am going to have to pull the actual bed surface off, the sticker that came with it from Wanhao. In doing that, I really don't want to put a whole lot of pressure on these little bed leveling screws right here. So I will put some, these are actually threaded holes right here all the way around. I will put some 4mm screws in here to kind of support this, so when I flip it over to scrape that off, I won't be putting a whole lot of pressure on these little tiny bed leveling screws. I really don't want to snap those off. And then when I put this back together, I did find a 500 by 500 removable magnetic surface for this that I will definitely wait for it to come in the mail before I put a print surface back on this monster, because if you've ever printed anything decent size on one of these and you do not have any kind of flexible plate to get it off, it can just be a bear. And I found the magnetic sheet at actually at Ultimate 3D Printing Store online. It's an actual Wanhao part. It's actually made for this printer, so I'm pretty excited for it to come. It's not cheap, but I think it's going to be a big deal here. The one that I put on my Wanhao i3 is by far my favorite upgrade ever. It makes everything incredibly easy. So enough talking. I'm just going to start working on this and record as I go. So yeah, here we go. So I finally have the entire bed broken down, and now it smells like goof off in here, but man, this stuff is fantastic. I'm gonna give this one more clean because this is where the adhesive backing on the heater pad is going to have to hold on to it. And then I'm gonna work at getting everything lined up, get the pad lined up around the outside, make sure all the holes line up, and then I'm going to carefully glue my heating pad to the bottom of this. So I'll just have to make sure that everything's lined up. I'll probably use one of these bars to clamp it down on one end so that I can get the other ends adhesive started, and then unclamp it on that end and maybe clamp it over here and then roll it on nice and careful. This is the part that is at the front of the machine. So I need to make sure that my cables for the heat bed come out here. So that's important. They should come out like almost exactly the same spot. And yeah, so one more or two or three more, good cleans on this, and then I'll work on getting it sized up, lined up, and adhered to the bottom of the bed. This should probably not take that long. Once again, remember, number one, I'm not an electrician. This is just my idea. Try it at your own risk. Number two, if you like what I'm doing, click that subscribe button. It's right down below. Punch it. So I've taken all the extra hardware off of this, and that's right there is how the design comes into perfect play. I've got absolutely holes in exactly the right place. At least they're close enough for what we're trying to do here. So then I am going to grab this aluminum bar, which needs to go under here. I can get myself a screw sticking up through there. I hope these screws are long enough. Sorry, I'm kind of working out of camera. Let's see if I can move that up a little bit. There we go. All I'm trying to do is get this bar kind of solidified on there, held down with couple of these screws so that I can position the new heater mat to be pretty much exactly where I want it before I remove any of the adhesive backing. So kind of difficult to do as I work from underneath. But I got two of the screws in. They seem to be just barely long enough, which is fantastic. So now I'm going to look on here and I'm going to make sure that this is, even though it's being held pretty well on that end, I can still manipulate it a little bit. Make sure that this is exactly where I want it, nice and even, fairly straight. That looks really good. So now what I'm going to do is I'm going to lift this side up, and I'm going to, this is the scariest part of all, pull off this adhesive protection here. This is why I put it underneath that bar on the other side, because it is holding this for me, so I don't have to worry about it moving as I go ahead and lay this back down, and I'll roll it like this and press that on there from the inside out. Hopefully I'm not getting air bubbles trapped. Just press it inside out, massage it a little bit, let that adhesive do its job. It really seems to be stuck on there quite well. So now I'm going to remove this support bar that I've got on there. There we go. Now I can lift this side up, get all the way underneath there to that adhesive. This seems to be this paper seems to be kind of torn into sections. So I'm ending up pulling it off in sections. I don't know if that is intended or part of the manufacturing process or just the way things happen. Trying very hard not to get my greasy fingers on anything as I do this. So now I can go ahead and lay this down piece by piece. And kind of massage it a little bit, work it in. See if there's any air bubbles, work them up and out. Keep massaging it a little bit from the inside out. Make sure it adheres. This looks fantastically solid and fantastically flat. So now I'm just going to go ahead and put that frame back on, and then I'll be ready to put it back on the D9. So I'm not exactly sure how tight to make these screws. I don't think it will damage the heater, but I don't want it to warp the aluminum plate. So I'm just going to go ahead and give them all, just check them and make sure they're all about the same tightness. Just by feel. And there we go, that's it. Time to put it back on the D9. So for right now, I got my D9 flipped on its side, flipped on its back actually, I guess you'd call it. I'm going to try to mount this hardware right here on this rail with some T-nuts. Now, I could move this later if I need to, if that's a bad position for it. But also remember, if this actually, even with a longer print, gets warm, it will then use the aluminum of the frame to keep itself cool, and that's a pretty hefty frame, so I think it'd have plenty of cooling ability. For now, I just leave that there. I don't know. I need to run some tests, so I don't know if I'm going to be able to hook that in right there or not. And then what I'm going to do is I'm going to run this thin wire from the output, the original output to my heat bed from the board, and I'm going to run it to this switch side of the solid state relay. Now I'm using a thin wire, and it's not going to really matter because I tested this solid state relay input for the solid state gate, and it literally draws about 10 milliamps, so really, really low amperage and 24 volts, and it works great. The only thing I'm going to have to do is on the main board here, the hotbed positive and negative is not listed. Let me show you that. So right here on the board is the connection for the hotbed that I've already disconnected, and they don't really mark it positive or negative because just when it's just going out to a heating element, it doesn't matter. So I'm going to have to find out which one of those is positive and which one of those is negative, because I don't want to send the wrong voltage over to my solid state relay. So that's on the list of things to do. But right now I'm going to hook those red and black wires up. So I'm going to go grab my soldering iron, some solder, and some spade tips, and I'm right back. These spade bits are way too big for this tiny, tiny wire, but they work really good with the terminals on that solid state relay. So I'm crimping them really carefully, and then I'm going to get some solder in there to finish the job. Now I can attach these right where they say they want to go. There's the positive underneath that connection. Negative underneath there. And then I need to solder some terminals on the other end. Okay, now before I can hook those up, I need to know which one of those leads is positive and negative, which I'm hoping that I can do by turning the printer on really fast, except I'm sure I'll have to plug in the bed thermistor so that I don't get an error on the board. So I'm gonna go get the bed and bring it over here and put it on. So I've got it back on. It's just temporary. I'm not gonna be able to level it or anything with it on here like this. Remember, these wires don't have to go into the bed, they have to go over here. And it looks like I got plenty of room under the bed there for my hardware over there. So this set of white high-powered wires, they just go down on the floor. But this one's got to come into the main board right here. Oh, I guess you can't see that. So this wire off my new heat pad, this is my new thermistor wire. It's got to go into the thermistor connection right there, labeled B temp. And the original one just came up through here. So I think that's probably good enough for me. And then I am going to go ahead and plug it into the B temp. Now, the polarity on this one's not going to matter because it's not that type of device. So I may actually want to zip tie that eventually. But for now, I just want to make sure I can get a reading to push some voltage to this hot end connection right here so that I can check and find out which one of these is kicking out positive. Then I can hook up my solid state relay. So now the printer is actually on. I don't know if you can hear the fan running. And I'm going to go ahead and take this bed up to, let's try 10 degrees C. And it should be kicking voltage out here now. So right there I can tell on the left is positive. So then I will hook this up like so. And so now when I tell the bed to heat up, I should get a light over on my solid state relay. So I'll set it back for 10. Bed is kicked on, and I do have a light over on my solid state relay. So that's fine. I'll turn that off before it believes that it is not working. And then in order to do a full heat test, I'm going to hook these up over there and see if I can actually get it to heat up. Okay, now it's all hooked up. It's not pretty yet, but I am going to heat it up for real. Actual heat, actual power. I'm going to tell it to go to, just take it easy, just go up 20 degrees. That'll be fine. I have my kilowatt plugged in still, so we're still looking at about 700 watts on the heater. The bed is in fact heating up. I can feel the bed getting a little bit warm. And let's see when it gets to its supposed temperature, if it cycles. We should see this red light go off. There it goes. Cycling off. Bed temperature should come back down and it should cycle right back on for me. The bed right now on my app is telling me that the actual bed temp is 21.3 C, and my infrared no touch thermometer is telling me it's at 25, 26 C, so it's a little bit off, which is fine. I'll figure that out when I go to print and just set up my G code. Should be cycling back on anytime. Red light should go on. There it goes. Cycling back on to keep the heat right where I put it. I think I'm going to call that a success. Cycles on and off just fine. Hooked up to the printer. Bed's getting warm. The reading's pretty close. Just have to adjust a few degrees in my slicer settings. What a deal. Now I just got to button this baby back up. Get my magnetic build plate on there that's coming in the mail. And I can start printing. So I just wanted to show people what I've done on this to get this project finished up. I have the wire here for the temperature sensor. It's taking basically the same path as the original wires did up through the hole in the main box for the D9. It's plugged right in right there into the temp for the bed temp. Over here I have these units attached to the frame. This one did not attach the way I wanted it to, so I 3D printed this bracket and made a cover for the hot wires that are right across there. This right here is main voltage that's on whenever the printer is on. If you remember in the video, I actually hooked a cord to this that was its own cord that went into the wall, but I changed my mind on that because it's too hard to manage the multiple inputs and have hot wires when you don't know you have hot wires. So I actually ran a wire. This is a 16 gauge wire. I ran this 16 gauge wire up behind here and into here, and I've connected it to the main connections, the neutral and the line connections on the power supply. So now if I do reach around here and turn the printer off with the main switch, it actually will cut power to all of this stuff down here. Now on top of that, because I don't want these wires to be open, out in the open, in case something falls on there. These ones are low voltage, remember, but those ones are high voltage. I don't want those to have the chance to get something to fall on them. I actually printed this shield that snaps on. I don't know if I can do this with one hand. I'm using my cell phone for this because I wanted to get in a little bit closer than my tripod camera can. So then this shield snaps around that solid state relay. So I've got everything covered, heat shrinked, covered, attached to the frame, nice and solid, ready to go. And now it's time to button the printer back up and flip it back right side up. So I'm going to run the same experiment that I ran before this whole mess started. I've got my linear rail attached to the bed. I've got that washcloth in there just to help the camera focus, so don't just ignore that. But I'm going to heat the bed up to 60 degrees C, and we are going to watch in time lapse and see how much that linear rail moves to indicate if the bed is still in fact warping under heat. So here we go. I've got the temperature set for 60 C, and we'll see what happens. We are currently at 30 C, and I do not see that moving one bit. We are right now at 40 C, and I still don't see that raising up one bit. I'm seeing no bow or no heat flex in this bed at all. According to my infrared thermometer, in the middle we've got 43 C, and on the edge we've got 42 C. Well, in the corners we've got 40. So we're at 2 or 3 degrees difference. We are currently at 50 C, and there's no flex in this bed at all. That is exactly what I wanted to see. There we are, 60C, and that is not flexing one bit. I have absolutely no warp in this bed at all. Absolutely flat all the way to 60C. If you remember, when we did this experiment before the new heater, I had 5.5 millimeters of rise on this side, which means that the middle of the bed went up at least 2.5 millimeters, and the sides may have gone down. I mean, I don't know. I didn't really track it that close, but this rod right here rose up because of the heat warp in the bed. It rose up 5.5 millimeters. And when you're talking about a layer on the bed, or your first layer on your bed is 0.2 millimeters, 0.3 millimeters, that kind of flex makes a huge difference. That right there is a win. Well, Grim 3D family and fans, I'm calling that a win. That was a big project. I'll have some links to the stuff that I purchased in the comments below. Check that out if you want. Just remember, if you order from the guy I ordered from at Aliexpress, you have to contact him and tell him what voltage you want it in. Okay, he's used to making the 220 volts for a European market or elsewhere in the world. In America, if you're in America, you're going to have it done at 120 volts, but he was really good. He contacted me back within, I don't know, probably within 36 hours. So it seemed to be pretty responsive. The install worked pretty well. I'm pretty happy with it. I've got some pretty decent safety on the side. I've got the wattage of that thing turned down. Just that 12 or 1300 watts was too much. As the printer runs right now, with the hot end going and the fans going and the heater going, it pulls about 850 watts. So even with the motors running and everything, when it's full printing, it should be below 1,000 watts, which is right where I wanted it to be. I did in fact buy a heavier power cord to go from the wall to the printer, because a lot of those computer style power cords are like 18 gauge. I bought one that was 14 gauge. Okay, the 18 gauge doesn't really want to mess with that kind of stuff. So I've got decent overhead in my wattage on my wires, decent overhead in my solid state relay. That thing can handle 3 times the amount of power I'm putting through it, maybe 4 times. I've got plenty of headroom in my fan controller that I put on there to control the wattage. That thing can handle 4,000 watts, and I'm not even pushing half of that. Even if it was full blast, I wouldn't even be pushing half of that, which it's not. So I've got all the wires covered, I've got them all contained, and I've got everything plugged into the wall with one plug to avoid the confusion. And yeah, it does get confusing. I actually blew a breaker earlier today because I thought wires were dead that were actually hot. So stay safe. Remember, I am not an electrician. I just do this for fun. Try it at your own risk. It's totally up to you. It seems to be a great project. For me, it solved the problem of the heat warp on the bed that was just screwing everything up. The auto bed level couldn't keep up with it because, in my opinion, it didn't stay the same. We had a maximum of 5.5 millimeters of flex on that thing, but then after it sat for 30 minutes or 40 minutes, it went down to about 2.5 millimeters. You're well into a print by then. Anyways, that's about it for this episode of Grim 3D. I probably didn't make it in my 10 minutes, so oh well. Better luck next time. Remember, subscribe if you want to. Family's getting bigger. I'd like to see it go through the roof. Leave a comment. Just keep it civil. Smash that like button. Ring that bell. We'll see you out there.